Take a look around the room you're in. It's nearly impossible to find an object that an engineer was not involved with its design and production. It's also quite challenging to find a product that a mechanical engineer has not contributed their knowledge and skill set to. From producing the products that we know and love, to enabling a sustainable future for humanity, mechanical engineers play a fundamental role in societies across the globe, especially in the manufacturing setting. If it were not for the manufacturing industry, civilizations would be nowhere near as technologically advanced as they are today. Today, we will talk to you about the major industries that mechanical engineers currently reside in and what kinds of opportunities are available in those respective industries. The aerospace industry is a promising field for new mechanical engineering graduates. The Bank of America predicts the space industry to triple to a $1.4 trillion market by 2030, which will bring with it many employment opportunities. This coincides with the growth of private companies like SpaceX that are launching rockets at unprecedented rates. Luckily for GT grads, Georgia has the largest aerospace cluster in the Southeast because of companies like Gulfstream Aerospace. As a matter of fact, manufacturing accounts for about 65% of all employment in the Georgia aerospace sector. The Bureau of Labor Statistics estimates that over 5,000 new positions in manufacturing, design, R&D, and government by 2030 will be present in the aerospace sector. Major companies like SpaceX, Blue Origin, Gulfstream Aerospace, and Lockheed Martin are actively hiring mechanical engineers for the production of their aerospace systems in the following areas. In manufacturing, machining skills and knowledge of structural analysis and material science are crucial. In vehicle and engine design, companies are looking for CAD and FEA skills, along with knowledge of fluid mechanics, thermodynamics, and heat transfer. And in avionics, programming skills and electronics knowledge is necessary.
The next industry we wanted to talk about was the energy industry. According to the United States Department of Energy, manufacturing is the lifeblood of the American economy, which is further supported by the pivotal role it plays in the energy industry. Renewable energy alone is projected to grow in net worth to 2.172 trillion United States dollars by 2030. According to Deloitte, there are 5 main trends that we are seeing so far in renewables: a growing interest in next-gen clean technologies, a boom in solar energy usage, offshore wind taking off, an increase in supply chain strategies, and circular economic pathways that ensure sustainability in the energy industry. What's great about these trends is that they prove that there are so many opportunities for new grads. Top energy moguls like Tesla, Rivian, and Shell are always looking for energy PMs, energy storage designers, and machining engineers that can help their companies go to the next level. These jobs require knowledge of a variety of things, such as data analytics, thermodynamics, hands-on manufacturing techniques, and more.
An industry that is also exhibiting a lot of current and projected growth is the medical device industry. One of the current trends pushing medical devices as an industry is the growth of cybersecurity in the medical field. As the Internet of Medical Things grows, the security of devices integrated with it need to grow to meet the potential danger of all these larger scale systems being hacked. In addition, there will be a greater demand in general for medical devices due to greater older population. As such, devices for surgeries more frequent in older individuals, such as cataract removal and joint replacement, will also need to be produced. Lastly, there's a growing field in medical devices to reprocess single-use devices for additional uses. Currently, they're preferred because it's cheaper and easier to throw out old equipment after each use, but there's a growing global pressure to switch to reusable devices to help combat the wastefulness of single-use products. So where do you fit in as an engineer? Well, the top 3 employers in medical device design and manufacture are J&J, Abbott, and Medtronic. Within these companies, there are a range of positions that need to be filled that include but are not limited to medical device design, where skills such as human factors engineering and CAD, like SolidWorks or CATIA, experiences are needed; manufacturing, where experience in machining, GD&T, and CNC are needed; and quality engineering, where attention to detail and a solid understanding of statistics are needed to ensure that only quality products are delivered to customers, especially when life or death can be on the line in hospitals.
Since the installation of the first moving assembly line by Henry Ford, the transportation industry has been synonymous with manufacturing for over a century. In 2020, 14.4 million cars were sold, and the industry generated $1.3 trillion of revenue. This includes a 20% drop from previous years caused by the coronavirus pandemic, and the industry is steadily recovering. It is estimated that 5% of all U.S. jobs are directly influenced by the strength of this industry, while nearly all other American jobs are indirectly supported by means of commuting, shipping, or transportation. Though personal transportation dominates in the United States, there has been a steady movement towards increased use of sustainable public transit, which the Department of Transportation cites as contributing to a healthier environment and expanding business opportunities, removing a car as an expensive obstacle for the working class. The three largest employers of U.S. automotive manufacturing are Ford, Toyota, and General Motors. Roles range from technical-oriented positions such as design and hardware engineers, who need to be well-versed in embedded systems technology, CAD, thermodynamics, prototyping, and controls. Other roles, such as project management, require skills such as lifecycle management and technical documentation to keep all stakeholders informed. New positions are developing all the time, such as the immersion of autonomous vehicle development, which requires intense knowledge of radar and sensor integration.
Continuing with industries that are important for mechanical engineers to look at is the micro and nanotechnology field. Currently, the micro and nanotechnology industry is younger than the other mentioned industries, but is growing at a current value of 1.76 billion US dollars, and is projected to reach 33 billion by 2030. There are many applications for nanotechnology, including all those aforementioned industries, but I'm looking at the electronics and IT side of things. In the Internet of Things and big data, the decreasing size of sensors is allowing for more sensors to be placed everywhere and allowing the sensors to be able to communicate with one another to process more and more data and model the environment clearer. In consumer electronics as well, Moore's law is a good example of how nanotechnology has increased the speed of which transistors are placed on dense integrated circuits and is expected to double every 2 years. Some employment in micro and nanotechnology that is important to document is the major employers are TSMC, AMD, Intel, and Apple, which are all very tightly related to each other in the semiconductor and computer chip manufacturing industry, as well as Thermo Fisher Scientific, which produce sensors for research and development. Some major skills that were common across all of the industry employers were thermal modeling for the computer chips that produce more power and get smaller each time, as well as mechanical design and analysis with finite element analysis for the structural integrity as temperatures increase. Finally, in conclusion, the role of manufacturing on all industries is very important. All industries need manufacturing, and in turn, they need mechanical engineers. Different industries, however, lean heavily on different classes that students here are taught. Some common skills that are valid over all industries are rapid prototyping, such as CAD, as well as design using machining and analysis and critical thinking, with common knowledge being manufacturing, thermodynamics, as well as programming, among other classes that tech offers for engineers. These are our references.